30, 60, 90 triangle. Okay. Well, X is this big angle here. So remember when we have two intersecting lines, they're opposite angles. They're called vertical angles, though that name is not tested. They're equal. So the big angles are equal to the big angles, and the smalls are equal to the smalls. So these two triangles represented here have the same degree of measurement, because this is a 90 and that's a 90, and then whatever these two are the same, but it shows us what it is, 145. That's correct. This is 145 and X is 145. Excellent. If we just solve for this angle up here, it's going to be 35. This is a line 180 degrees minus 35 is 145. Okay. Great job. Cooking along. We have 4 more problems to do in this session. This is a fun problem. I really liked this problem. It states in a sequence A1, A2, A3, so on. A1 equals 5 and A2 equals 10. And any number a to the n plus 1 is equal to a to the n raised to the power of a to the n minus 1 for all values greater than 2. When this is, I forgot to put that in, for n is greater than 2. Obviously the first 2 doesn't apply to this. And the example they give us is a to the 3 is equal to 10 to the 5. If you put in a to the 2, which is 10, and you move it up, you'll figure that one out. So our question is, what is the least value of n such that a to the n has 5 million digits? Least value has at least 5 million digits. Good problem. Yeah, I got I got confused on that one. Don't worry, I got it. Get confused on these ones. Well, that's why I put it in. Us math teachers love to confuse people. No, I saw this problem, and quite frankly, I guessed. And I got the right answer through guessing. And the one thing is just looking at these values here. On this type of problem, if it's 4, 5, and 6, 10, and 10 and 100, I'm going to guess that the answer is going to be 4, 5, or 6. Because 100 is just like monstrously huge. Because this is raised, each number is raised to the power of the number before it. So a to the 3 is equal 10 to the 5. So let's do 5. You're confused and then you get the right answer. You're not confused. You're right on. The answer is 5. If you go in and you do a to the 4. A4. Not a to the 4. A4. What? A to the 4 is equal to, let's put in a to the 3, a sub 3, which is 10 to the 5th. Got to know your powers at 10 for this test. So 10 to the 5th, 10 to the 6th, so on and so forth. Then this is raised to the power of a to the n minus 1, which is a to the 2. It's 10. So a to the n, a to the n plus 1 is equal to a to the n times a to the n minus 1. Well, I have to multiply these two exponents out. This is an exponent. So this is equal to 10, 50. And 10 to any power will give you the number of digits. So 10 to the 1 has 2 digits. 10 to the 3 has 2 digits. 10 to the 4 is 3 digits. 10 to the 2 has 3 digits. I'm sorry, I said that backwards. 10 to the 2 has 3 digits. 10 to the 3 has 4 digits. I am typing that down because I'm saying that. The powers of 10. Number of digits. So 10 to the 2 is 100. And that is 3 digits. 10 to the 3 is equal to 1,000. Obviously, 4 digits. And it goes on and on, such that what we're looking for is 5 million digits.
10 to the 5.
It's really, we're looking for 10 to the 5 million. So if I just go one more, a to the 5 is going to equal 10 to the 50 multiplied by 10, or the exponent, raised to 10 to the 5th power. Times 10 to the 5th. It's 50 million. It's 5 million, excuse me, not 50 million. Simple math. Is 10 to the 5 million, which is, stop that. I did that wrong. Yeah, 6 digits, 50 million. There you go. That's right. That's at least 5 million digits. Knowing your powers of 10 is a very important thing because it also works in scientific notation. This could easily be a scientific notation problem of population growth, of fruit flies or something. Okay? How'd that explanation work? It's a hard problem to explain this way. Tried. Okay. Practice that one. You have my email address now. The one thing that I do for everybody is if they are practicing problems for the GRE GMAT and they've taken one of these courses or they work with me as a tutor, can send me problems at any time. And now one of the things I have to do, the ability to do is with my new pen I've been recording, is you can send me a practice problem. I'll type it up. I can solve it and video record it. And you can just watch it on YouTube. So I'll do any problem for anybody. Yeah, just send me a problem anytime, because then I'll use them again. I'll use them on another test session. So I actually enjoy it. What are you studying? What are you studying? GMAT or GRE? GMAT. Okay. What are you using to study from? Was it a book or a piece of software? Manhattan prep course. Okay, I haven't done any of their problems yet. I've heard of them, I think.